on Monday and Tuesday, we were looking at how to solve equations with a graph, right? And when we solved the equations with the graph, how did we know where the solution was on a graph? You can tell me that. Oh, how about I just ask somebody? On a graph, Mikai, how did you know what the solution was? Okay, when you plugged it in, that's how you check it. That's great. When you plugged it back in, but on the graph, what would you see, David? Beautiful. So it would be the point where the two lines intersect. But what we found was that that wasn't always the easiest way to solve it. So what we need to do is we need to have some other methods. And some of you may remember these from Algebra 1. But if you don't, that's okay. We're starting it over again so that you can see. So here's a nice system. Theoretically, we could graph this thing. One of the methods we're going to look at is called substitution. We've got a couple of days for this lesson, so we can delve into another one called elimination. But for right now, we're going to look at this process called substitution, which means we're going to work it out so you're replacing one thing with another to help you get those ordered pairs without ever putting it on a graph. So today's not a graphing one, today's a finding in a different way. So our first step, if we're going to solve by substitution, is going to be to take one of these equations, and it doesn't matter which one, and you need to solve one of the equations for one variable. So you're going to isolate one of them. Solve one equation for one variable. So out of these two equations, which one to you looks easiest to get one of the variables by itself? Would you say, Madison? You said something, didn't you? Oh, Santi? The second one? And Santi, which one did you say? The second one looks easier. Which variable is easier to solve for? Y is easiest to solve for because it's almost by itself already. So what do we think, Alex, as far as what we would do to get that Y by itself? Almost. Good. So we'll take away the 2x from both sides on this one because this is the easiest one to solve for one variable. So everybody needs to write it down. And when we do that, we've done our first step. We've gotten y equals negative 2x plus 10. So this is our first thing that we do. After we've gotten one of them isolated, we need to use the other equation too. Remember, the solution has to work in both equations. So when you're solving, you have to make sure you've used both equations. So what we need to do next then is we need to substitute what we got into the other equation where the y lives. Okay. We're going to substitute what we got into the other equation. So those of you that like highlighters and colors or whatever, if that helps you, that's how this is arranged like this. So this part right here is going to get dumped right into the other equation where the y is. So what this looks like is 3x plus 4 times this y came out. This got substituted in equals 12. And from there on, you need to solve the equation. I don't even have that listed as a step. And then once you solve it, you'll substitute it into the other one. So I want you to take a minute and I want you to work on solving. So you're going to distribute this 4, do all the steps to go down, and I'll put the thing on pause and then we can take a look at that in a minute. And just as you solve your problem, be very careful as far as when you distribute, watch out for your negatives. And then as you go through and you move things over, once again, watch for negatives. It is okay to get a decimal. especially since you're using calculators now, you can get a decimal. If the decimal ends, go ahead and keep that decimal. But if the decimal repeats or it goes off the end of the calculator, please change it into a fraction. Then that way it's the easiest to work with. And also, if you round a number, it ends up giving you an answer that isn't 100% correct. And then when you plug it in, you're compounding the problem and getting an even more wrong answer. So please make sure that you only round it if the decimal actually ends. After you've done that and you found the answer, you need to substitute it into the other equation or into either equation. There's two equations. Remember, this is supposed to solve both of them. So it really shouldn't matter which equation you choose to plug into. And we solved x. So it's probably the easiest to plug it right into this one where y is almost solved for anyway. Theoretically, you could plug it into any of the equations along the way. We could plug it into this one also. And as long as you haven't made any mistakes, you'd have the right answer come out. So we'll plug it in. I've chosen to plug it in right here. Again, substitution. Even our elimination method that we'll have involves a little substitution. So we do have to be able to remember that we're looking for an ordered pair, not just one answer on these. And you do have to plug in at the end to find the other number. So 2 times 5.6 gives us 11.2. And then subtracting from both sides gives us negative 1.2. So we've gone through, we've got our whole answer. We've substituted again. Now we have an x and a y, and it's important that you put your final answer as an ordered pair. 5.6, negative 1.2, the x goes first, the y goes second, and we have an answer. These answers will work in both of the equations. We didn't have to graph it. As we can see with the decimals, it would have been super hard to find that ordered pair with a graph, because you would have had to make your graph actually go by the 10th place in order to land directly on it, and it's not conducive to using a graph a problem like this. So we need to have our second way of solving. And substitution works great in some cases. There are some problems like this one where substitution is possibly the easier way to do it, but then there's other methods. And when you get a problem, you might want to evaluate, well, what's going to be my easiest way of solving any particular problem? Okay, everybody good? All right, let's take a look at this one. We want to go through, we want to do the same process. And just to get you started, which one of these equations is going to be easier to solve for an individual variable? First one, Jasmine, why? Because x is already by itself up here, so we're going to use this first one. So when we move it right along, and we get this one so that the x is by itself, what do we get, Ebony?
For the first one, we get y equals negative 3x plus 5 over 3. So the first one, what are we?
If you're trying to get the x by itself for this.
Oh, no, minus x.
Minus, okay. If you were trying to solve for y, yes, you'd subtract the x, but if you're trying to solve for x, what do you do?
Oh,
minus 3y, and that's much easier. Technically, you could do what you said, so you're not necessarily wrong, but it's going to make a harder problem. So we're going to do this one, solve it for x. You don't always have to solve for y, because x is almost solved for already. So x equals negative 3y plus 5. Then after that, Ian, what do? Plug it into the other equation. Now be careful that you're putting it in for the x and not putting it in for the y. Make sure you're very, very conscious of what you solved for, because that's a common mistake, is people accidentally putting it in for the wrong variable. So be careful on that. Do exactly what he said, and plug it in there. So it goes into the other equation. I'll give you a minute now to go ahead and solve, and then we'll come back. All right, so after you solve this and you distribute, watch out for negative times negative makes positive. And then putting your like terms together, don't forget to do that. Make sure you acknowledge the difference between putting like terms together and doing the same thing to both sides. From here to here, we added 10 to both sides, and then divide by 2, and we get 2.5. After we do that, we need to then take the answer we got and substitute it into the other problem. So we need to put it in here because you always need it to find an ordered pair. Once again, pick the easier one to work with. If something's almost solved for, make sure that you are solving for that one. So we'll take that 2.5, put it in for the y, and then work our way through solving it. So we get 7.5. Then don't forget when you subtract from both sides, 5 minus 2.5, and you could get another decimal like that. And then our final answer is an ordered pair. What's my ordered pair look like? Angelia, what's the ordered pair look like for that one? Yep, negative 2.5, 2.5. Yes. Okay, so now the domain and the range are actually the entire list of numbers, not just an individual number in an ordered pair, but you mean the x and y. So I'm just clearing that up because I think you knew what you were saying, but I didn't want anybody else to be confused. So like the domain and range for these would be like all real numbers, because the domain, you're going to find an x in any kind. But the x and y values, now if the x and y values are the same, it doesn't necessarily mean that they're right angles though, to answer your other question. It just means that the place that they would intersect would be at, if you connected that line to the origin, you'd get a 45-degree angle. That's about the only thing I could say about that, but that's not even part of the solution. But it does not imply a right angle. So it's good to ask the question, but it doesn't, so you know. All right, so negative 2.5 and 2.5 is our answer. That's our 1 point, our one ordered pair that makes both of these true. So if we were to graph it, you would graph them, they would intersect each other, they would cross at negative 2.5, 2.5. Now, I did mention that there's another way of solving, and we are going to delve into it a little bit today, but not the harder ones for elimination. We have substitution, which is great. Elimination sometimes makes the work easier and faster, so we're going to take a look at that. I said sometimes, so you have to self-evaluate whether you like the elimination or the substitution for any given problem. So elimination works on the idea that it's mathematically okay to add the same thing to both sides, so the addition property of equality. And so since these two equations are both equal, okay, this is equal to this is equal to this, if I add my left sides together and I add my right sides together, it's still true because I've added something equivalent to both sides of an equation. So when I add these two equations together, what we see is that 2y and negative 2y are opposite of each other. So what's going to happen to them? They're going to cancel out. They're going to turn into a 0 because 2 minus 2 is 0. So there are going to be no y's left. Okay. One piece is opposite of the other piece. 2y and 2y give you 0y. But then we're left to add the other pieces. So we have the 3x and the 5x, which gives you 8x, the 14 and the 2, which gives us 16, and the 2y and the negative 2y cancel out because their sum is 0. So there's nothing left for that. Then 8x equals 16 is super easy to solve. The answer 8x equals 16 gives you what? 2. So x equals 2. So right off the bat, you can see that that was much easier than trying to get a y by itself and plugging in this case, because these two pieces were equal and opposite. Makes a very nice way of finding. We have to substitute a little in order to find the y value. Neither one of these actually jumps out as being particularly easier. A lot of times people like to work with positive numbers better, so you pick the positive one. But either one you pick, you're going to pretty easily get the right answer. So we'll take that 2. We're going to plug it in for x. I chose the first equation, but feel free to choose the second one. You'll get that answer. We plug the 2 in. We do our little algebra steps. 3 times 2 is 6. Then we take away 6 from both sides so that 2y equals 8. Y equals 4. And in a very nice, no muss, no fuss type of a way, we end up getting our nice ordered pair, which is 2, 4. So this needs to be gone. Here's our ordered pair, 2, 4. Bless you. Okay, so anybody lost on any of these steps right here? Yes, yes. All right, let's look at another one. Because this was really nice because they were equal and opposite. But the problem here is we have a pair that's equal. The 2x and the 2x look like they're almost ready to cancel out, but they're not opposite of each other. So we're going to have to do a little something to make them opposite of each other. The 2x plus 3y equals 9, I'm just going to bring that over. And keep in mind that this looks like it's almost ready to cancel out. But if I tried to add it right now, I'd get 4x. So it's not ready yet. So what we want to do is we want to try to do something to this to make it into a negative 2x. Such as what? Good. Multiplying by a negative 1 is going to really take care of it, because that'll change this one into a negative and they will cancel out. It doesn't always have to be the y's that cancel out. So if we do times negative 1, we multiply the whole thing by negative 1, not just one piece. Because remember, mathematically, we have a multiplication property of equality, which says it's okay to multiply both sides by the same thing. So negative 2x plus y equals positive 1. Negative 2x plus y equals positive 1. And I've got this circle here for eliminating because the 2x and the negative 2x then just cancel right out. And the 3y plus the y gives us how many y? 4y, and the 9 plus 1 gives us 10. Then you divide both sides by 4, and we get 2.5. 2.5 isn't always the answer. It just happens to have shown up. And then what do we do? Good. Substitute it into something. Doesn't matter which one. You found y, so please make sure when you substitute, you carefully put it in for y. Don't put it in for x. And you might be choosing one that I didn't choose. That's fine. I chose that one. But once again, you'll get the same answer both times. If you didn't get the same answer both times, then you've done something incorrect. So 2x plus 7.5. Take away your 7.5 from both sides. Divide it by 2. Don't round your answer. 0.75 ends nicely. Most of you know as a fraction, what would that be as a fraction? 0.75? Not 1/4. 3/4. Okay. Think money. Okay. When you have 0.75, think that's 3/4, right? Literally, you're thinking 3/4 in your hand. That's 75 cents. Yes. Here you would, if you did the other equation, yes. So if I put in 2x minus 2.5 equals -1. Sorry about that. It doesn't show up very well like this. I should be using the other one. So if we do that, that's what it would look like, and you'd solve from there. You would still end up with the same answer. We're still going to get 0.75. When I add this over, I'll get 1.5. So you'd still end up with 2x equals 1.5. So 0.75, 2.5 would be our final answer on that. Okay. Any other questions? All right. So we're going to take a look at this word problem. Let's go through it a little bit and jot it down so you can understand it and we can think about it. You have $77 in your pocket in $5 bills and $1 bills. So you've got 5s and 1s in there. And you have a total of 41 bills in there. Okay, that's a little, yeah. So you probably would try and go somewhere and say, do you want change? Because nobody wants to have 41 bills in your pocket. But assuming that this is true, maybe you had a bake sale or something and so you had all this. So 41 bills are in there in 5s and 1s, and you have a total of $77. And we're going to ask the question of how many bills of each do you have? Now, in the past, what I've seen from some of you is people spending a lot of time, because I look at your work sometimes on like bonus questions, and people spend a lot of time on guess and check. Guess, in other words, you put in some numbers and then you multiply them times 5 and multiply them times 1 and see if you got the right answer, and you just keep guessing and checking. Okay, that's not a good way of doing this. It's not very efficient. And what if you have, the reason we do these little easy problems is so that you can figure out a method, so that you can do more difficult problems and make sure that you're knowing what you're doing. So as much as guess and check gets you by, if you do that on this quiz or this test, you're not going to get all the points, because it will say write the equation. You have to need to learn the method rather than just guessing and checking. So in other words, we'd have to set up an X and a Y. And X would be the number of maybe $5 bills or $1 bills, and the Y would be the number of $5 bills, but we have two variables to represent the number of which type of bills. Okay, this is a really common type of a word problem to see. Those of you that are getting ready to go to college, when you go in for your entrance exam, they place you, yes, they give you in math, just so you know, public service announcement. If you get really good grades and then your SAT score backs it up, they will probably just place you based on that. However, there are some schools that even with the SATs, they give you a placement exam, such as, like, I think, I'm pretty sure Rutgers does that. And they said they don't allow calculators on it, by the way, because we visited Rutgers and they said that. Listen, however, there are certain schools that will allow you to place out of that with a really good SAT score. But many of the schools do it. RCBC, they have the placement test. Most of the schools will have a placement test for you so that they can tell where you are. And remember when I went in, they had us do placement tests. If you don't score well enough, or you score at a certain level. Okay, everybody would score at a certain level, and they use that to determine your math class. There have been people who have gone and slid by and then didn't quite score high enough on their placement test, and then they ended up having to take math courses that didn't even count towards their degree, and then they have to build up to being able to. So please, please, please make sure that you're good and steady. Take those placement tests very seriously, because they really do. They set your level and determine whether those courses that you take at the beginning are counting towards your degree, or you have to build up to the ones that you have to take for your degree. So let's make sure we have methods here. This is a very common type of problem. X equals the number of $1 bills, Y equals the number of $5 bills. We need two equations for that. One of them has to do with the value of them, and one of them has to do with the number of bills. Can somebody give me one of the equations that you're expecting to see? Let's think about this number of bills one. If I have 41 bills total, what happens with X and Y? Okay, now 5x would be a value and 1x would be a value, so that wouldn't equal 41. That would be, that's a money value. But what does equal 41? Okay, your value one would equal 77, good. So 5x plus 1y equals 77. What about the 41? X plus y, good. X plus y equals 41. 5x plus 1y equals 77. Two equations. We have a value equation right here. 1x plus 5y equals 77. And then x plus y equals 41. This is our number of bills equation. I think we may have said it backwards earlier. But the $5 bills are the y's, so 5 times y, 1 times x equals 77. And x plus y, number of bills. So then you can solve it either way. You can either solve it by elimination, or you can solve it by substitution. I've chosen to put in, I believe, substitution here, but either one will work. So if we solve this one for x, and then you plug it into the other equation, negative y plus 41 equals 5y. We have an equation, a thing we can solve by a method, rather than taking the time to guess and check a whole bunch of numbers, which you might, at your first guess, you might guess one, but you might be checking so much that it's more work to do guess and check. So a method really does help you. 5y minus y gives you 4y. Minus 41 gives you 36. So y equals 9. What does that 9 tell you? You have 9 what? You have 9 $5 bills. Good. And then we find the number of $1 bills. Use the other equation. This one's easier. X plus 9 equals 41. And many of you, even with just the words, would be able to say, oh yeah, I know I need to take my 41, take away my 9, and find out that I have how many bills, how many ones. Yes. 32 $1 bills, 9 $5 bills. And this is easy enough to go back. Always take your numbers and mentally go back and make sure they make sense. 32 ones would give you $32. 9 fives would give you how many dollars? How many? 45. So 32 plus 45 gives you $77, and they do add up to 41 bills. So it makes sense. You've done a word problem. It hasn't been horrible in your life to do the word problem. Setting it up, taking that little bit of time to set it up, saves you a whole bunch of plugging and filling in and checking and filling in and checking and filling in and checking. And it's not that hard. It's a very common type of math problem. So make sure that you're studying, make sure that you're doing your homework well and carefully. And so that's this part. Now elimination does go upscale a little bit, so that sometimes when we do elimination, there's something to do first to make it cancel out besides just multiplying times -1. But this half of the assignment, when you do it for homework, is dealing only with the ones that are ready to eliminate or the ones you have to multiply by -1 so that they'll eliminate. The other half of the assignment is going to be where we go back and we have to multiply by something else. So on Friday, what's due is both halves of this assignment, 29 and 30. Okay, neither one is humongous. So if I were you, if you have a little time this afternoon, I would get a start on it so you get this part as much under control as possible. And then the other part, 30, deals with the rest of elimination. And so it is broken down into those two pieces, those two assignments. Both happen to be due on Friday. Okay, hold up a second.